Hi students, welcome to the next session, comparison and integral test. So comparison and integral test, we are going to see the problem definition of comparison. Comparison test, if two positive two-term series summation un and summation vn such that if un less than or equal to vn for every n, summation vn converges. Then summation un is also converges. Next condition, if un greater than or equal to vn for every n, summation vn diverges, then summation un is also diverges. Note, if summation vn converges and limit n tends to infinity, un by vn is equal to finite, then summation un is convergent. That is, if you take the limit summation un by vn, the value is finite value, then summation un is convergent. If summation vn is diverges and limit n tends to infinity, un by vn is equal to finite, then summation un is divergent. Next note, if limit n tends to infinity, un by vn equal to 0, the test become fails. That is for both the convergent and divergent. Here, if vn converges, then the limit un by vn finite. If summation vn diverges and limit un by vn equal to finite, this is called the summation un is divergent. Next, geometric series. The geometric series 1 plus r square plus r cube plus etc. plus infinity converges if modulus r less than 1, diverges if or modulus r greater than or equal to 1, and oscillatory if modulus r less than or equal to 1. Next, we are going to see the problem. Test the convergence of the series summation n is equal to 1 to infinity 2n plus 3 by n into n plus 1 into n plus 3. Solution. So let us say how to consider un is equal to summation n is equal to 1 to infinity 2n plus 3 by n into n plus 1 into n plus 3. And have to consider vn is equal to, that is highest power of n in the numerator divided by highest power of n in the denominator. So consider this un. See here, the highest power of n in the numerator is n. In the here consider the denominator. The highest power of n in the denominator is n cube. So here we can cancel the 1n. So we get the result 1 by n square. So this is only our vn. Next, summation vn is equal to summation 1 by n square. So which is convergent since p value is greater than 1. By using the p-test, here the p is equal to 2. So p is equal to 2 is greater than 1. Therefore, the summation vn is convergent. Next, we have to find the limit n tends to infinity un by vn is equal to limit n tends to infinity 2n plus 3 by n into n plus 1 into n plus 3 into vn values 1 by n square. So taking the reciprocal, we get the n square equal to, so from the numerator can take out the n outside. So this can be written as 2 plus 3 by n. In the denominator we can take here one n, then here one. So totally we have the n cube into 1 plus 1 by n into 1 plus 3 by n into this n square. So already here n is having, cancel the 1n. So remaining the denominator we have a n square having. So cancel the n square. Therefore next apply the limit n tends to infinity. So in the numerator we get the value 2. In the denominator we get the value 1. That is here 3 by infinity if you apply we get the value 0. 2 plus 0 is 2. So finally we got the result is equal to 2. This is a finite. If summation vn convergent, this is also finite, then the series is a convergent series. By comparison test, summation vn is convergent. And also summation u is also convergent. Next we are going to see the next problem. Test the convergence of the series x by 1 into 2 plus x square by 2 into 3 plus x cube by 3 into 4 plus etc. Solution. Let us consider un is equal to x power n by n into n plus 1. Now if you apply n is equal to 1, so we get x by 1 into 2. Now similarly, apply n is equal to 2, x square by 2 into 3 plus etc. So on you will get. Next let us consider Vn is equal to, that is the numerator, we doesn't have a highest power of n. So we can write numerator is equal to 1. In the denominator the highest power of n is n square. So therefore Vn is equal to 1 by n square. So now we have to check. Now apply the limit n tends to infinity un by Vn is equal to limit n tends to infinity x power n by n into n plus 1 into n square. So from the denominator take out the n outside. So in the way outside we can write n square into 1 plus 1 by n. So now cancel the n square, remaining we get limit n tends to infinity x power n by 1 plus 1 by n. Now apply the limit n tends to infinity. So here before applying the limit, so now we have to give the value for x. When x is equal to 1, the limit n tends to infinity un by Vn is equal to limit n tends to infinity 1 by 1 plus 1 by n. So here n is equal to infinity, apply 0, you will get the finite value. But Vn is equal to p, that is p is equal to 2, that is greater than 1. Summation Vn is convergent. Here this is a finite value. By comparison test, summation Vn is convergent. Therefore summation Un is also convergent. Hence summation Un is convergent when mod x less than or equal to 1 and divergent when x greater than 1. That is, if you apply x is equal to 1, we get the result finite value. Suppose if you give the value x is greater than 1, that is if you give x is equal to 2, so we will get the divergent. Next problem. Test the convergence of the series 1 by 1 plus x plus 1 by 2 plus x plus 1 by 3 plus x plus etc. Solution. Let un equal to 1 by n plus x. And also consider Vn is equal to the numerator no highest power of n. So you can write the 1. The denominator the highest power of n is n. So write here the denominator. So consider the Vn is equal to 1 by n. Now limit n tends to infinity un by Vn is equal to limit n tends to infinity 1 by n plus x into n. So from the denominator take out the n outside, can be written as 1 plus x by n. So now cancel this n. So remaining we will get limit n tends to infinity 1 by 1 plus x by n. So now apply the limit x tends to infinity. So we get the finite value. That is anything by infinity will get the 0. So 1 by 1 is equal to 1. By p-test, summation Vn is divergent. That is here the n power 1, that is p is less than or equal to 1. The p is less than or equal to 1, it is a divergent. It is a divergent, this is a finite value. By comparison test, summation Un is also divergent. Next we go to the integral test. Let summation Un be a series with positive and decreasing terms un greater than or equal to u2, greater than or equal to u3 plus etc. Next let f be a non-negative decreasing function in the interval 1, infinity, then integral 1 to infinity f of x dx is finite if summation Un is convergent. Next point, integral 1 to infinity f of x dx is infinite if summation Un is divergent. That is, the integral value is finite, then summation Un is convergent. If the integral value is infinite, then the summation Un is divergent. Next problem. Test the convergence of the series e power minus 1 plus 2 e power minus 2 plus 3 e power minus 3 plus etc. Solution. Let us consider Un is equal to n into e power minus n. Let f of x is equal to, just replace un here x. So we'll get the x into e power minus x. So here you're taking the summation n tends to 1 to infinity, f of x is equal to summation n is equal to 1 to infinity x e power minus x. F of x is greater than 0 and f of x is decreasing in 1 comma infinity. Therefore, integral 1 to infinity f of x dx is equal to integral 1 to infinity x e power minus x dx. By using the Bernoulli's formula, so we get the result is x e power minus e power minus x. The limit is from 1 to infinity. Now applying the upper limit, e power minus infinity value is 0. E power 0 value is 1, but here the 0 into anything is this term fully equal to 0. Then this is also e power minus infinity is 0. Next applying the lower limit, so minus, that is upper limit minus lower limit, that minus e power minus 1. Then here become the plus e power minus 1. So finally we got the result 2 e power minus 1, which is equal to 2 by e, which is equal to finite value. That is integral value is finite, then this is called the convergent. Therefore, integral 1 to infinity f of x dx is convergent. By using the integral test, summation un is also convergent. Next we go to the next problem. Examine the convergence of summation n is equal to 1 to infinity n by n square plus 1. Solution. Given un is equal to n by n square plus 1, let f of x is equal to, just to replace n by x, we get x by x square plus 1. Now taking the summation on the both the sides, so we get summation n is equal to 1 to infinity f of x equal to summation n is equal to 1 to infinity x by x square plus 1. That is, here f of x is greater than 0 and f of 1, f of 2, f of 3, all the values also equal to greater than 0. Therefore, f of x is decreasing in the interval 1 comma infinity. Next, now we have to find the integral for f of x function. So, integral 1 to infinity f of x dx equal to integral 1 to infinity x by x square plus 1 dx. The integration of this one is, here the denominator, if you differentiate the denominator, you get the numerator. Therefore, we can use this case as log x. So, here differentiation of x square is 2x. So, not having the 2, so therefore multiply 2, then divide 1, 2. So, we get 1 by 2 integral 1 to infinity 2x by x square plus 1 into dx. Then, which is equal to 1 by 2 log of x square plus 1. Apply the limit 1 to infinity. Now applying the limit, so we get the result. That is, if you apply the upper limit, you will get the log infinity, minus if you apply the lower limit, you will get the log 2. So log infinity minus log 2 will get the infinite value. That is, integral value f of x dx is infinite, then the series is called the divergent series. By integral test, summation un is also divergent. Next problem. Show that summation n is equal to 1 to infinity 1 by n square plus 1 converges. So here u of x is equal to, you consider as 1 by x square plus 1. Now taking the summation on the both the sides, summation n is equal to 1 to infinity u of n is equal to summation n is equal to 1 to infinity 1 by n square plus 1. That is, here u of x is greater than 0, then u of x is a decreasing in interval 1 comma infinity. So now we are going to take the integral on both the sides. Integral 1 to infinity u of x dx equal to integral 1 to infinity 1 by n square x square plus 1 into dx. So integration of this one is tan inverse of x. Now applying the limit, we get the value pi by 4. So this is a finite. The integral value is finite. Then this is called the convergence. Hope you all understand this integral test and comparison test. Shall we see the next remaining test in the next class? Thank you.